So we're gonna do this backwards today. We're gonna do our notes first, and then if we can get to your homework, we will go over it. If we do not have time to go over your homework, we will start with the both homeworks on Monday, because I won't be here tomorrow. But the work that you do tomorrow consists of stuff from today, so we have to get this section done. So I want to do it first, and then if we have time to go over some of the homework from 5-2, we will do that. If we don't have that time, then we'll do it on Monday. So you just hang on to your stuff till then. Yes.
I'll say if we don't, then we keep it.
Yes. Everybody good with that? All right. So 5-3, solving trig equations. When solving trig equations, you should write your answers using exact values rather than decimal approximations. So on the first examples, we're going to put our like terms on the same side. So your like terms would be your sign values. So we're going to take the sin x plus the square root of 2, and then we're going to add sin x to the other side. Now you can put your two signs together. So I have 2 sin x. Then treat this like a regular equation. How would I solve for x? Subtract square root of 2. So I get 2 sin x equals negative square root of 2. How do I get sin x by itself? So we get sin x equals negative square root of 2 over 2. Where have we seen that? On the unit circle. Yay. So where is it on the unit circle? Think about sine. What value has to be sine? Your y coordinate has to be a negative 2. So if we think about our, I'm sorry, a negative square root of 2 over 2. If we think about our coordinates, these are positive. All right, this is negative, positive, negative, negative, positive, negative. And they're at the 45s, right? Right. So square root of 2, 45, then we have a 90. What would this one be? No, not negatives. No, not your coordinates, your degrees. So I good with that? Then we have another 45 down here. What would that one be? Are y'all questioning it like you're not sure? How would I find that actual degree for those people that are like, I don't know where they're getting this? 180 plus 45, 225. Then I would do 270 plus 45 to get this one, which is 315. All right. So where are my y values? Negative. Three and 4, right? That's at 225 and 315, but I need it in exact values and not, remember, we don't really use degrees, we use radians. So how can I put this in radians? Okay, so I know it's 225 times pi over 180. So just 225 over 180, 225 over 180 gives us if you already knew that that was 5 pi over 4 because you knew the unit circle, but I feel like you guys know degrees better. Okay, so that's why I went with degrees. Your other degree is what? 315 to get it into radians. When you in here now, you might as well. No, I'm just kidding. No, you're fine. You know you're fine. No worries.
14 minutes, actually.
Oh gosh, Brady, get it together.
Right, man, he's my messenger.
My carrier pigeon. Thank you, sorry about it.
All right. So we have these two values, but tell me what you know about the sine graph. Tell me what you know about the sine graph. What's this? So it just keeps repeating itself, right? Right, that's fine. So are these the only two values where it'll be negative square root of 2 over 2? Yes or no? No, why? Because I could do a full circle from there, and then I could do another full circle and another full circle as many times as I want to, and it's still the same answer, right? So how can I write that? Okay. So a lot of times what they'll say, these answers right here, these are from 0 to 2 pi. If they limit you 0 to 2 pi, that just means the unit circle. Use just the values on the unit circle. But this one didn't give you those values, so it wants every one of them. So it wants the one on the first revolution, the second revolution, the third revolution, the fourth revolution. The way we do that is we write a general form. So I want you to understand.
Last name M and N. Please report to the commissary for the registration time. Letters M through N.
So we're going to start with that 5 pi over 4. Bye. You got up like super serious. Running. I said, you got up like super serious. And then how do I get back to that on that next revolution? How much do I go? 2 pi, and then I go, and then I go as many times as I want to, right? So we write plus 2 in pi, because it could be 1 time revolution, 2 times revolution. That's where the n's coming in. In this case, it'll be the same thing for 7 pi over 4. How do I get back to it? I have to go a full revolution, and I can do as many as those as possible. That's why the n is there. Again, we use 2 pi because it's a full revolution to get back to it. Typically, they're going to limit it. Okay, so we're going to write general ones, but most of the time they're going to look for a specific one. Okay, so this is the same exact question, except we have a minus square root of 2. So how did I solve? I added the sign. So if I add sine x, what do I get? 2 sine x. I got a minus square root of 2 equals 0. Add the square root of 2. And then what's the difference? It's a positive. So I'm going to go back up to the top. There's my negatives. Where were my positives at? What value? So what degrees? 45 and 135. So sine x equals square root of 2 over 2 at 45 and 135. How do I get it in radians? If you already know the radians, you can use those instead of having to convert it. 45 over 180 is pi over 4. 135 over 180 is 3 pi over 4. But again, it didn't say anything about limiting it from 0 to 2 pi. It wants a general solution. So these would be 0 to 2 pi. What would your generals be? How do we write a general on the last one? Because to get back to this 45, what do I got to do? A full circle, full circle, full circle. So what do I do? plus 2n pi. And the other one is going to be? That's your general solution. Okay. Also remember, and I'll put it back down in a minute, your period of your sine function is 2 pi. We should kind of know that. Remember, it takes 2 pi, a full revolution, to get from 0 to 0. So like on your graph, to do that full wave goes from 0 to 2 pi. So that's your period, 0 to 2 pi. Okay. What's the next trig function we're dealing with? Tan. So remember when we graphed tan, we went from, let's just say we go negative 2 pi to 2 pi. And I told you about pi over 4. You go pi over 2, it doesn't matter. And then those don't matter, so let's graph it. Nope, hold on. Sorry, I had to reset the calculator. All right, so each one of these little lines, guys, each one of these little lines is going to be your period. So where does this one stretch from? I went by my little marks are pi over 4s. So what would these be? If this is pi over 4, what's the next one going to be? This is 1 pi over 4. The next one would be, or just pi over 2 to pi over 2 is how long? Negative pi over 2 to positive pi over 2. 1 pi, right? So the reason I'm telling you that, the period for tan is not 2 pi. So when we write that general form, we're not going to use 2 pi. Okay. And again, why? Because the period of tangent is only 1 pi. And then it starts repeating itself. Work it the same way. How do I get this tan by itself? Move the 1. And then remember that tan squared x is the same thing as tan x squared. So how do I solve that? When I square root a fraction, I square root the top and the bottom. That gives me that tan equals, what's your square root of 1? Can I have a square root of 3 in the bottom? So what do? Which gives you square root of 3 over 3. How many answers are there to a square root problem? What are they? Positive and negative. So I know I squished that in there. I'll try to take that out. 1 positive, 1 negative. Think about these. Where would these happen? First of all, if I have a square root of 3s, where's it going to happen? Your 30s, 30, 60, 90, 30, all those, right? So let's look. I don't think I have any circle filled in. Back at your unit circle, what I'm talking about, you would put these. What's your ratio, guys? What's your ratio for tan? Y over x. So we would put y over x right here. So 1/2 over square root of 3 over 2. Does everybody understand that? Okay. My question is, does that give you that square root of 3 over 3? Let's try it. What? What do we say that one was? Could you eat a little louder? ah. What do we say it was? What was that ratio? Okay, we don't divide, so if you guys look, your twos will cancel out and you're given 1/√3, which is what we had at the beginning, right? So where would that be positive? What was that? What was that coordinate at? Which is what in radians? Perfect. Go over it again. Where were we at? Sorry, y'all. On our unit circle, we used this coordinate, right? So we were at 30. We have to have the same coordinate, but it can be negative. Which one? Which is? Which is what? 5π/6. Does everybody understand where those are coming from? All right. Why don't I pick anything out of the third or fourth quadrant? What is my period for tangent? What is my period for tangent? Just pi, which is the top half of the unit circle. Then it will start repeating itself. So the bottom half, it's already repeating itself again. Does everybody understand? What does it repeat itself by? What's our period again? Pi. So instead of 2πn or 2n⁻, what are these going to be? πn. So π/6. And I do n⁻. But if you do πn, it's the same thing. Or 5π/6 plus n⁻. All right. So instead of using the unit circle, I did that twice, right? Is everybody good with that? You don't have to use the unit circle. How can I solve this equation right here if I'm looking for the x part? How can I find that little x right there? Sort of. What does that mean? The inverse, the tan inverse. So check this out. If I do the tan inverse of 1/√3, and I put it in degree mode. Why would I put it in degree mode? Yeah, because I can convert degrees easier than I can radians, right?
Right.
So √3, what did I get? 30. Does everybody see that 30? And then I can change 30 into π/6. So you don't have to use the unit circle. I just wanted to relate it back so that you guys could see it. So don't stress out about that at all. Well, what about 5π/6? How would I get it? Not the second half. It's still in the first half. You do a negative one. Let's try it. What happened there? From the 180 back 30. Yep, but you got to remember to go from where? 180 and not 360. So be careful about that. Correct. All right, solve 4 sine squared x minus 3 = 0. What do I do? We're back to sine. So what is our period for sine? 2π. So over here where it says n⁻, we're going to change it back to 2n⁻. So how do I solve this? So I get 4 sine squared x. We're going to add 3. So sine squared x equals 3/4. Square root both. We get sine x equals square root of 3/2. Remember, it's positive and negative. How many times does sine square root of 3/2 occur in the unit circle? 2π. How many times do you have a y coordinate of positive square root of 3/2 or a negative square root of 3/2? More? 4, 1 in each quadrant, right? Everybody good? So there's a positive in the top, and then there's a positive in the next one, and then there's a negative and a negative. Everybody good? So through that whole thing. Well, where are they at? Where are they at? Remember, we can try it. How do we put this in our calculator? Sorry, I didn't hit second. Of, which gives me 60 degrees. How do I fix that into radians? Just divide it by 180, right? Math enter gives me 1/3. That's, what else would I put with that? Okay. If you have like your full unit circle, it might be smart to get this out. If you don't, it's all good. I mean, you're just gonna need to look at it today. You can look at your book. So those of you that do have your book, where else do we have our y coordinate as square root of 3/2 or negative square root of 3/2, the y coordinate? And tell me the radians. So in quadrant 1, it was at pi/3. Where is it in quadrant 2? 2 pi/3. How do I finish writing that? 2m pi. Where does it happen in quadrant 4 that we have a square root of 3/2 in the y? 4 pi/3. And then what about in quadrant 4? Square root of 3/2 in the y. 5 pi/3. Does anybody not know what I'm talking about right there? On the unit circle, yes, that have square root of 3/2, whether it's positive or negative. You have 4 because there are 4 places that I would have a positive square root of 3/2y or a negative square root of 3/2y. So for this one, because what did we do? It was what kind? This one was just negative. It was not positive and negative because we didn't take the square root. But then right here, we did the positive. So if it was something like sine squared, where we had to square root it and it gave us positive or negative square root of 2/2, we would have all 4 of these. So that's why. Is it very good? All right, flip it over. The equations in the previous examples involved only one trig function. When 2 or more functions. So what it's saying is it only had sine, or it only had cosine, or it only had tangent. Occur in the same equation, collect all terms on one side and try to separate the functions by factoring or using appropriate identities. So what you've done the last couple of days. This may produce factors that yield to no solutions, such as the following example. All right, so it does have a solution, but it has, you'll see. All right, we're going to solve cotan x times cosine squared x equals 2 cotan x. So we're going to get everything on the same side, get it equal to 0. How do I do that? What do you notice about both of them? They both have a cotan, right? So what can I do? Take out that cotan, leaves me with? -2. When you factor and you're trying to find your answers, so like if we factored x -2 and 2x + 4 equal to 0, what you technically do, I taught you 2 user methods, everybody else did too. You're actually setting both factors equal to 0 and then solving. So you would add 2, subtract 4, divide by 2. Okay, that's what we're going to do now. We're going to set each factor equal to 0. So we're going to take that cotan x and set it equal to 0. And we're going to take cosine squared x -2 and set it equal to 0. Tell me what cotan is again. It's the opposite of. It's the opposite of tangent. What was your ratio for your coordinates of tangent? Y over x. So this should be x over y. So where would I get 0? If I had cotan equals x over y, what would have to come on top? A 0. So I need where my x coordinates are zeros. Where is that at? At 90 degrees. Which is? Radius. /2. What was your period for tan? Also your period for cotan. So how do I make this general? There is nowhere else from 0 degrees to 180 degrees that you have an equation, not an equation, a point that has a 0 in the x. Does everybody understand that? So the only place it can be is here. So this is your only answer. Well, what about this? We would add the 2 and then square root it, right? Okay, so let's check that out. Cosine squared x equals 2, square root it. How do I solve that? How do I solve it? Oh. What did I get? Doesn't work, right? So for this one, there's no solution. So that's what it's saying in the top, is sometimes that factoring will make it yield no solution for that one, but this is our actual answer. So this would be the answer that you do. This one doesn't count because it doesn't give you a solution. It's kind of like those extraneous solutions and stuff like that. All right, same concept. How do I solve the next one? This one's easier because it's sine squared and sine. It's not like we have to change it or do anything crazy. What did I do on the last one? Yep, first thing was to get it equal to 0. So I take sine squared x -2 sine x. Gracious. What do you notice about both terms? So we can factor out a sine x. So we are left with sine x -2. We're going to take each factor and set it equal to 0. What's your period for sine? To be able to get 0, where would it be? What has to happen for this to be 0? Which coordinate is for y? I mean, for sine. Y. So my y has to be 0. Let's talk about the unit circle. Where is it 0 at? 0. Where else?
180.
Which is pi. Where else? 2 pi. You cannot forget to put the 2 pi on there because it goes from 0 to 2 pi. So how could I make this general? Here's your general form. 0 pi, 1 pi, 2 pi, it'll go 3 pi, 4 pi, 5 pi. So what can I change this to? Say it again. Use this. What did I do to make it general? Add what? Add 2 n pi, but this one we're just gonna add to n pi. Let me explain it one more time. 0 pi, 1 pi, 2 pi, 3 pi, 4 pi, 5 pi, 6 pi. So we can just replace all those numbers that we're changing with what? N. Does everybody understand why this one is n pi? Okay. So there's your first solution. What about this one? What would I do? You should know that this is probably not going to work. It might. We'll check it out. How do we figure it out? Inverse sine of 2, and I got an error. So this doesn't work. Your only thing is n pi. Equations of quadratic type, many trig equations of the quadratic type. Ax squared plus bx plus c. Ax squared plus bx plus c equals 0. That'll be shown below in just a minute. To solve equations of this type, factor the quadratic. Or when this is not possible, girls that were in here during advisory, use the quadratic formula. Didn't even know, did you? Okay.
I know the quadratic formula. Can we say it?
No.
Actually, I would.
Well, you're not the boss, so don't say it yet. Fill in the box and then you can tell me what it is, okay? Quadratic in sine x. So if you have 2 sine squared x minus sine x minus 1 equals 0. Remember that this is the same thing as 2 of sine x squared minus sine x minus 1 equals 0. Quadratic in secant. Bless you. Secant squared x minus 3 secant x minus 2 equals 0. And remember that secant squared x is secant x squared. So those are just some quadratic forms. Stay here. What is our quadratic formula? Yeah, oh yeah, it's your turn now.
Negative b plus or minus the square root of b squared minus 4ac all over 2. Yeah.
Flip it over.
Oh, wait.
I didn't do anything. Whoa, 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 whoa.
I'm not writing the quadratic formula.
Okay, don't.
It's ingrained in my head, and then.
Andy, can I go now?
Yeah.
Are you sure?
No problem.
I mean, I don't want you to yell at me or
I
anything.
don't know. I did not yell.
I love how somebody else in here was like,
I love you, Michelle. I did not yell at you. Well, we're gonna have. You did say that.
I don't love little boys.
So you hate your kid?
Sometimes very much so.
Oh. That's.
I mean, and his mom hates him every day.
This is true. And my dad's in Vegas, so I'm literally at the house. while I'm in Vegas. So I've got. a house.
And you need a place to stay.
Yes,
I got you.
please. I can't,
Alright.
I already can't stand my little brother, and then it's just mom.
So now the 10th graders, last name O and P, to head to.
All right, when we're working on this next example, think of it, guys, just like I was showing you yesterday. Instead of thinking of it in terms of sine, think of it like sine is your x value. So how would I factor this problem? I'm going to do it over to the side so you guys can see it. How would I factor 2x squared minus x minus 1? Side and divide. It's okay. You were trying hard. Do not. I don't have time for criers today. She made herself cry if she cries. I'm not yelling at her. It's okay. You did a great job. For some reason, every time I say something like that, people think I'm yelling at them. It's okay. You did a great job. Stop yelling at me. All right, cool. Factors of -2 to add to -1. Yep. And then do what? Divide by 2, right? So we would get x minus 1 and 2x plus 1. But instead, what are our x's? Sine. So when we factor this, sorry, we would have sine x minus 1 instead of x minus 1. And we would have 2 sine x plus 1 gives us 0. Everybody okay? Okay. If you can do it with the sign, that's perfectly fine. If not, do like this and change it and then put it back. Okay. Not a bad deal. Sine x minus 1, we're going to set that factor equal to 0. 2 sine x plus 1, set that factor equal to 0. And then solve. How do I solve the first one? So how do I solve that then? Sine inverse of 1 gives me 90 degrees, which is pi over 2. And it says from 0 to 2 pi. You guys see how this interval happened right there? So we don't have to put any of that plus 2n pi or anything. That's our answer for that one. How do I do this one? So 2 sine x, subtract 1, divide by 2. Where are my values of y equal to -1/2? So look at your, makes it a little bit easier. There should be 2 places. Where they at? Where my y coordinate is -1/2. Radians, please. That's it. Any questions? So like I said, it's much easier when they limit it to 0 to 2 pi. Their exact answers, you don't have to put plus 2n pi or plus n pi or anything like that. All right, how do I do the next one? What am I actually factoring? How would I write this in terms of x? Okay, how do I factor that? Divide and divide. So I get x squared minus 3x plus 2. Factors of 2 that add to -3. And then we have to divide by 2. So the first factor is going to be x minus 1. The second factor is 2x minus 1. So instead of x's, what do we have in our problem? So sine x minus 1, we've already done. 2 sine x minus 1. Is it equal to 0? So the only difference is a minus 1 instead of a positive 1. So we've already done this. Sine x minus 1 equals 0. I'm copying it from up here. So sine x equals 1. Where is your y coordinate? 1. It is at 1 on pi over 2. Again, we already did that at the top. For the next one, we're going to add 1 and divide by 2. Where do we have positive 1/2 y coordinates? So y coordinate is 1/2. I'm sorry, go ahead. Pi over 6 and 5 pi over 6. Very good. Rewriting with a single trig function. What's wrong with these? We have a sine and a cosine, so we need to fix it. The one you can fix is the squared term. Okay. This is where your identities from yesterday come in. I can make this look like cosine. What is sine squared x? Go back to your like your front sheet from the other day, or look in the front of your book at your Pythagorean identities. Tell me the tell me the actual identity. It's sine squared x plus cosine squared x equals 1. So if I want to solve for sine squared x, what do I need to do? Okay, so that's what I'm going to do. 2 times. You said I had to take 1 and subtract cosine squared x, and then finish out the equation. Plus 3 cosine x minus 3 equals 0. All right, so one more time, I'm looking for sine x. So sine squared x is 1 minus cosine squared x, and that's where this comes in. Distribute, clean it up, then factor. Okay, distribute, clean it up, then factor. So if I distribute in here, I get 2 but I can keep cleaning up because I have a 2 and a negative 3. What's the problem? What would I be factoring? Like if I did it like I did the last ones, what would I be factoring in terms of x? Negative 2x squared. What's wrong with that? I didn't hear you. It's a negative. We don't factor with a negative in front, right? So how do we pull out that negative? What do you do to everything? Just change the signs. That's all you need to remember. Change the signs. Don't divide by a negative, not multiply by a negative, not factor out a negative. Just change the signs. So we're going to change them all. And as long as you change them all, it is mathematically correct. And now I can factor. What am I factoring? In terms of x. And how do I factor that? We already did this, right?
Yeah.
Okay, so remember we did it right here. So what are we going to end up with in the end? Is everybody okay with that? Go back and look. If you have them, go back and look, and then don't do all the extra work. So instead of x this time, we're going to have cosine x minus 1, 2 cosine x minus 1. How would I solve the first one? Add 1. So we get cosine x equals 1. On the second one, How would we solve it? Add 1, divide by 2. So cosine x, you said add 1, divide by 2. Cosine is which coordinate? Tell me where the x coordinate is 1. Yeah. 0 and 2 pi. We're going to talk about this in a minute. All right. What about where the x coordinate is 1/2? Which is pi over 3 and 5 pi over 3. So again, we were looking for our x coordinate to be a positive 1/2. Did it give you a domain? No. So what do I have to make sure I do? Do we add 2 in pi or do we add in pi? How do you know? Cosine is just like what? Sine, it's just shifted over, right? So it's still going to be that 2 pi, it just starts at a different area. So the length is still going to be 2 pi, it just starts differently. So our values, how could I write this one? So this would be 0, it would be 2 pi, what else would it be? 4 pi, it would be 6 pi. So this is how you write it. It can't be in pi because I can't include 1, 2, I can't include 1, 3, 5, 7, 9. So it can't be in pi. It's got to be 2 in pi so that I can get what kind of numbers? Even numbers. Does everybody understand that? So that one is 2 in pi. What do I have to do to these two? Add 2 in pi. So pi over 3 plus 2 in pi. And 5 pi over 3 plus 2 in pi. Okay, again, we had to do this so that we could have even numbers. All right, so what do you think we do on the next one? Which one are we gonna fix? I would fix secant tan as one of your general ones, so I'd fix it so that's not a ratio, weird ratio or anything. And I can do tan in the calculator, right? Yes, I can't do secant. Well, I can, but I can't. When I try to do the inverse, tan inverse will go in your calculator. So what's your Pythagorean identity with secant squared? Say it, the whole thing. 1 plus tan squared equals secant squared. So we're going to change secant squared into what? 1 plus tan squared x. And then we have minus 2 tan squared x minus 4 equals 0. What do I do? Distribute, and I get minus all the rest of it, 2 tan squared x minus 4 equals 0. What do you notice? Yeah, so these two are like terms. We can put them together. What's 3 minus 2? Just 1 tan squared x. And I heard somebody, what 3 minus 4 is? -1. How would I solve? So I get tan squared x equals 1. All right, let me do this. Let me show you. This is fine. This might make the front easier. I can change this. Just bear with me. I'm sorry I made you erase if you're erasing. Change this to x squared minus 1. How do we factor x squared minus 1? X minus 1, x plus 1, right? So this would be tan x minus 1 and tan x plus 1. All this is doing is splitting it up. You could do it the other way and it's perfectly fine. This means that tan x is going to equal a +1 and a -1. If you take the square root, how many answers do you have? So the square root of 1 is 1 and -1. All I did was split it up. You could do it the other way, retake the square root, it's fine. I just wanted you to see both of them separately. All right. So I need to figure out where tan x is equal to 1. So look on your unit circle. What would I have to have? Hold on. What coordinates would I have to have to get a 1? The same coordinates. So that's going to be square root of 2/2, right? So where do you have 2 coordinates that are positive, square root of 2/2, or 2 coordinates that are negative, square root of 2/2? Pi/4 and 3 pi/4. Can we get a -1? Think about this. What's your period for pi? I mean, God bless it. Your period for tangent. So it can only be in the top, right? So we don't use any in the bottom. So that's why there's only 2 answers on here. Why? Because how do I fix these to general? That will pick up the 2 on the bottom. So it's like repeating yourself to write the 2 on the bottom. Does that make sense? All right, if you need to write that, don't forget only the top, because the period is pi. So we only use the top of the unit circle values. Next. Sometimes you must square each side of an equation to obtain a quadratic. As you will see in the next example, because this procedure can introduce extraneous, what's that mean, extraneous solutions? Bad ones, absolutely. They don't really work in the problem, they just happen to show up. You should check any solutions in the original equation to see whether they are valid or extraneous. Why haven't we done it before? Because we haven't squared something, okay? We haven't squared something. It's only when you have to square. All right, so it says find all the solutions of cosine x plus 1 equals sine x in the interval from 0 to 2 pi. From 0 to 2 pi. There's absolutely nothing I can do with this. So what I can do is square both sides. I can't fix regular cosine, I can't fix regular sine. To be able to fix them, they need to be what? Squared for our Pythagorean identities. Everybody understand that? So why did I square it? Because I can't fix it until I do square it. How do you square this? All right. You square the first, cosine x times cosine x is cosine x squared or cosine squared x. Then you multiply them together. So what's 1 times cosine x? And then multiply it by 2, because there will be 2 in the middle that are the same. So 2 cosine x. And then you square the last 1 times 1 is. Do y'all need to see like this? X plus 1, x plus 1. You would do x times x, which is x squared. X times 1 is x. 1 times x is x. There are 2 of them in the middle. That's why it's 2 cosine x. And then 1 times 1 is 1. Everybody understand that? Okay. What? I feel like our relationship is going downhill, Dylan. Real fast.
I guess you gotta move him back up here.
No way. I'm just kidding.
Pretty
I'm
please.
just kidding. And then sine x squared is gonna change to. Sorry. Yeah, sine squared x. But I need all the same type of terms. I can't have a cosine and a sine. So which one should I change? The sine, because there are more cosines than there are sines. So cosine squared x plus 2 cosine x plus 1. Remember, our trig functions are our identities. How do I get sine squared x by itself? 1 minus cosine squared x. What do I do now? Move everything over, get it equal to 0 so we can factor it if we need to. So I'm going to do this all at the same time. I'm going to add cosine squared x. And I'm going to subtract 1. So that gives me 2 cosine squared x plus 2 cosine x equals 0. What do I do now? Take a 2 cosine x out, which leaves me with cosine x plus 1. How do I solve? Set each one equal to 0. How do I solve the first one? So I get cosine x equals 0. The second one, we have a -1. We're on the interval from 0 to 2 pi, so just the unit circle. Where is my x coordinate? 0. And we're using the full unit circle. Is there anywhere else your x coordinate is 0? 3 pi over 2. Where is your x coordinate? -1? Yep, there's only one of those. And then what it's asking you to do is check in the very top that these work. How do you do that? You literally plug them in. I'm going to go back to mode because I'm plugging in radians. And I'm going to go back to the very beginning. Cosine of pi over 2 plus 1. Does that equal sine pi over 2? So that one works. We can box it. So this one works. Everybody good? What's wrong?
She's waiting until we get
Oh.
there. It's her birthday, Miss Joel.
Happy birthday. We can try 3 pi over 2 and sine 3 pi over 2. Are they equal? This is one of those extraneous solutions. This only happens when you square. I will go ahead and tell you that this one does work, but I just wanted to show you the plug-in and to show you one that does and one that doesn't work. And again, only when you square. So check extraneous solutions if you square. And why did we have to square? Because you can't do anything, and to be able to interchange them, you have to have the squared Pythagorean identities. Same thing on the next one. We're going to square them. Square the first term. You can sit up here if you're going to whisper all the time. If you're going to whisper all the time. Right. Why is it 2 sine x? And then just 1 equals cosine squared x. We're going to change this cosine squared to a sine. How do we do that? 1 minus sine squared x, right? And remember in yesterday's notes, you have that manipulated every way you need it manipulated. Or you can do it yourself. Add your sine squared x and subtract your 1. That will give me 2 sine squared x. I added sine squared x. I didn't touch the middle term. And when I subtract my 1, it's going to cancel out and give me 0. What do you notice? 2 and sine x leaves me with plus 1. Set both factors equal to 0. On the first one, how do I get sine by itself? Where on the unit circle do we have a what coordinate? What coordinate? Y coordinate is 0. Zero and 180 in radians is, we need to check those in a minute. On this one, our y coordinate should be -1. Where's our y coordinate equal to -1? Three pi over 2. We plug them back into the beginning and see if they match. 0 will, pi will not, 3 pi over 2 will. What? Okay, so make sure they're in radians because we're doing radians. You put this side in. So sine, our answer was 0 plus 1. And then you check the other side, cosine 0. What do we get? Both ones. If they're equal, it works. If we plugged in pi, so sine pi plus 1, and then cosine pi, we get 2 different values. So we know they don't work. Does that make sense? All right. What? What is 2 pi? But it is not included. Got it? Great question. Great question. Flip it over. Functions involving multiple angles. Guys, shh. The next examples involve trig functions of multiple angles of the forms cosine KU. That means there's a constant. And tan KU. Again, there's a constant and a variable. So like this one has a 3t instead of just cosine t. To solve equations of these forms, first solve the equation for KU. And then divide by the result K. All right. So if you look at all of these, they're all general because they don't go from 0 to 2 pi. So how would we solve this? We want to get cosine 3t all by itself. How do we do that? Divide by 2. And then what did it tell you to do? Solve the equation for KU. And then? Okay. So let's just start with cosine of u equals 1/2. So we'll change it to this. Where are values of x equal to 1/2? Pi over 3. And we want to go all the way around the unit circle because it's cosine. So that's the whole circle. Should be one more. 5 pi over 3. And then it tells you to do what? So your k is the number with the variable. So what are we going to divide by? So we're going to take pi over 3 and divide by 3, but we don't divide by 3. What do? So we're going to multiply this by 1/3. So what does it change into? Pi over 9. Same thing with the other one, 5 pi over 3. We're going to divide it by 3, but instead we flip and multiply and we get. Everybody okay with that? It's a general form. So what do I need to do to both of these numbers? Why is it 2 pi? Good. And make sure you put the n with it. 2n pi. And 2n pi. That's it. Okay, next. Two sine 2t minus square root of 3 equals 0. You can do these at the same time. You don't have to do like all 400 steps. So what would I do to get sine 2t by itself? Add the square root of 3, divide by 2. Remember, we're just going to look where our y value is a positive square root of 3 over 2. So look on your unit circle. Say it again. I cannot hear a word you're saying.
2 pi over 3.
I didn't get 2 pi over 3. Where your y coordinate is square root of 3 over 2. Maybe I did it wrong. I don't think I did it right. Okay, I think I did this one wrong. Keep going. Where'd you say? Pi over 3n. But what do I have to do to those? Okay, so what are you technically doing? Instead of dividing by 2, you're doing what? Times in the bottom by 2, right? So what's it going to change to? Plus 2n pi. Good. And 2 pi over 6 or pi over 3 plus 2n pi. Okay, we did pi over 3. We had to do times 1/2. 2 pi over 3 times 1/2. This gives you pi over 6. This one, your 2's will cancel out and give you pi over 3. You see it? Okay. This one, I think I can skip steps. No, you're fine. Honey. It's giving me a hard time. I am evil. Andrew?
1.
How do I solve the next one?
Subtract 3 by that.
When I subtract 3 and divide by 3, what do I get? Say it again. -1. Realize that this is the same thing as 1/2 x. Okay, so we're going to divide by what when we finish? 1/2, which means we're actually going to multiply by 2. Okay, we'll get there in a minute. Where is my tan going to be -1? And where do I look for this value on the unit circle if we're just dealing with tan? Just the top. Okay, so I need a -1. That means I need the same coordinate over the same coordinate, but one has to be positive, one has to be negative. So quadrant 2 is what I'm looking for. Why can't it be what?
Why can't you go to the corner?
What are we looking at? Just the top of the unit circle, right? Because we just have a period of pi, so we're just looking at the top. Where do I have a coordinate that's the same? Square root of 2 over 2, square root of 2 over 2, but one is positive, one is negative on the top half of the circle. Say it again. I'm going to divide that by 1/2, which means I'm actually going to multiply by 2 over 1, which gives me 6 pi over 4 or, and then how do I do general? plus n pi. Why n pi? Is everybody good? All right, next one. How do I do this one? All right, so I get tan of 1/2 x equals, I add 2, divide by 2, I get 1. Where is that value? I have to divide that by 1/2 or multiply it by 2, which gives me pi over 2. How do I write my general form? Flip it over. 2 more. All right. Secant squared x minus 2 tan x equals 4. Yep, turn secant squared x into, guys. Yes, so secant squared is 1 plus tan squared x minus 2 tan x equals 4. Put it in order and clean it up. What should come first? Mhm. How do I get it equal to 0? 1 minus 4 is? What do I do when I have tan squared and tan? Factor it. This is the same thing as x squared minus 2x minus 3. What are my factors of -3 that add to -2? So tan x minus 3 and tan x plus 1. How do I solve? Tan x minus 3 equals 0. Tan x plus 1 equals 0. And you said add your 3 and subtract your 1. Stop right there for just a minute. Do we have anywhere on the unit circle that we're going to get a 3 for our tan? No. So when you have this one, you're going to go back to your decimals. So how would I get that? How would I still solve this? So second tan of 3. Okay. All right. So x is going to be tan inverse of 3, which is 1.249. Can we get a -1? Where can we get that at? Three pi over 4. So both of these answers are right. We got to put them in general form. The way that they'll put this one in general form is they'll just do arctan 3. If you did tan it, sorry, that's a terrible 3. If you did tan inverse of 3, it's the same thing. If you did the decimal, it's the same thing. But what do I got to do to it? Put in general. And then your other one is normal, 3 pi over 4 plus n pi. Again, like I said, you could do arctan, tan inverse, or you can do the actual decimal. I don't care. Last one. What do I have to do? Find divide. So we have 4x squared plus 5x minus 6. Slide it over, we get x squared plus 5x minus 24. Factors of -24 that add to 5. 8, -3. What else do I need to do? I get. 4x minus 3. It's okay. So then our x's are what? Actually tan. So tan x plus 2, 4 tan x minus 3 equals 0. What would I do to the first one? Mhm. Is there anywhere on the unit circle that I would get tangent as -2? No, so listen, you can go ahead and write it out. Arc tan -2, how do I make it general? Plus n pi, that's your first one. How do I solve this for tan? Add your 3, divide by 4. Is there anywhere on the unit circle I can get 3/4? Say no. So then I can rewrite it as arc tan 3/4, but then I gotta make it general plus n pi. They are, they're just not our perfect ones. They're like a weird degree. Does that make sense? Like they're not our perfect ones. All right, listen to me carefully. 5.3, page 371, 6 through 10, even. 14 through 78, every other even. If you don't do it tonight, remember tomorrow you're working all day anyway. Okay, so all 3 homeworks, 5.2, 5.3, and the packet that you're getting tomorrow, which one, I mean, the work that you're getting tomorrow, is due Monday. Does everybody understand? So doing a little bit tonight only gets you ahead unless you just want to wait. And I mean, that's fine. You can do everything tomorrow in class.